Hello, everyone. Welcome back. My name is Turngo Anderson Gaji. You can also call me Dr. Turn or Turn. And today we're going to be picking up where we left off. This is going to be a long set of series. We will be in the last video recording. Let me stop this webcam. We brushed. We did some modeling, and we it the model the output was low to moderate, and we in this recording we're going to be fine tuning it through some sort of re-engineering to see if we can improve it. So this video might be kind of long. Basically, uh, we let me scroll the way down. Okay, this was the R square, which was about 35%, and the root mean square was that. So this, had it been this was at least close to the MAE, that would have been better. We can see if we can kind of like fine tune this through engineering to make it better. And for doing that, let me bring back the webcam. We can see if we can do that through moderation by using Andrew Hayes's. If you can get this book, this is really good. Model 3 regression. Model 3. Also, if you can get this, Jose, this shows you how to build composite variables for and then develop interactive terms. Okay, now that's what we're gonna do now. First off, in this video, I forgot to save this. This is the database, the SQL that I derived, that served as a database for that. And by the way, let me save this. I forgot to save it. Oh, I see an error here. Let me change that to E. And then let me save this. Control S. I'm gonna save this as insulin pred. Let me just do that and then we'll say insulin pred. Okay, that is saved, and then I'm gonna save this as also insulin pred. Control S. Let me see. I'm gonna say that and insulin pred. That should be good. Now we've saved that, and we're going to be continuing where we left off. Okay, so first off, I'm going to scroll the way in the bottom. With this model, we see that we are trying to see if we can improve it. So now we're going to say that, let me add more blocks as much as I can. Then change that to bookmark. Then I will say that fine tune. Or let me just say improve model by re-engineering. Okay, first off, let's find the age mean. I did not run this for a long time, so let me run all the codes before I will begin. I'm going to use kernel 3.10.9. Everything is running. Let it complete. It's still running. Okay, now that is done. Now next I will just say that for I in SQL columns, I'm just trying to pull up the column SQL data.columns print I just want to print out the column so that it will help me to build my composite. I'm going to copy it. Then I will say that I'm going to introduce new variables now. So composite variable SQL data I'm trying to get the mean for age now. I'm going to print that should work. Okay, so let's see what happened. Okay, so let me change this to just age and see if that works. I think I changed it to age, but I forgot. So let's run that. Good, it works. So that's the mean for age. Next, I'm gonna just copy. I'm just gonna go here. We will say that gender as coded as GD mean. We're just trying to save this so that we will create the. What I'm doing here is I'm trying to center the mean so that we will derive a. Let me just be sure that this was saved as gender. I think it was saved as gender. And then dot mean print gender mean. I love printing with aesthetics because it really helps. Now this is the age for gender. Well, basically, you know, I think it was coded as 1 and 2, you know, so it should be pretty much like that. Then next we will derive the mean for BMI. BMI mean SQL data. I think it was still BMI. BMI X BMI. Oh, I should have included square brackets here. Yep. Take that out. Take that out. Dot mean print BMI Okay, let's see what happened. So this does not work. BMI was saved as what? Let me scroll the way up and check that. So no SQL data. Oh, okay, it was saved as BMI. So let me change this to BMI only. Okay, BMI, and then run. Great. Now that is the mean for BMI. So here what we did is that we are creating let me just create I set up here, markdown, and I will. This is for you to understand what I'm doing. Compute step 1. Compute the mean for all variables. We have to do that if we want to, re-engineer. Now, next, we will step 2 here. I'm hitting M on my keyboard to convert to markdown. We'll say that step 2, create centered mean. Again, refer to Andrew Hayes and Jose. Andrew Hayes 2022 and Jose 2013 books that I just showed you. Variables. Okay, next. I would say SQL data we're adding these columns. AG is for age. SQL data age. That will be that minus AG mean. That is this AG mean that we created up here. Similarly, we will repeat this. I'm gonna pause this video and then repeat the whole process to make the video shorter. Okay. Okay, so I have finished typing this code. So if I run this, this will produce separate columns here. This is CM stands for centered mean for age, centered mean for gender, and centered mean for body mass index. Now we've created that. Next, what we're gonna do is we're gonna create our other composite variables for their interaction terms. So let me just change this one to markdown. Again, just click on click on here, then click M to change to markdown, and then you can start typing the steps, your notes. That's the proper term. So I'm just going to say create composite variables for interaction terms. Again, like I say, this video might be long because we are trying to fine-tune this and improve this model. So first I will say SQL data. I'm trying to add a column in here, and it should be interaction for BMI times age, and that will be SQL data. I'm just gonna come over here and here CMI. This one here. Copy that. Paste here. Times SQL CMI age. Where is age? That's the first interaction term. We're gonna do this for age, gender, and then all of the three. So let me pause this video and then do everything, and then I'll, just to make this video shorter. Great. Okay, so this is it. So it's gonna be the interaction between BMI and age, BMI and gender, age and gender, interaction between BMI, age, and gender. These are the additional columns that we're going to add, and then we're going to call out that to view what we have for the first 5, rows. That is from 0 to 4. This is what we have. These are the interaction terms that we're going to be including in our to fine tune this model. So next, let me just color these columns. SQ4. Let me just say Z in SQL data columns print Z. I want to print out the other columns to make it easier for me to copy and paste in my next code. Next, we will create our variables. So I'm thinking interact. Let me see. Because it's going to be a three-way model, I'm just going to say 3x. I'm trying to see what I can do. X var. Okay, the first one that I created was lower cases. So let me just say in all upper cases. X var is equals is not x equals is data dot loc, and then I would say for the columns, we're focusing on columns, so let me just the first here we're dealing with rows, so this is irrelevant. We're gonna go with columns now, so I'm just gonna do that. Come over here, select age. Next will be gender. Next will be BMI. This will be interaction between BMI and age. And this is very important. All the interaction terms will be added as well. That is why we created the interaction terms. The centered means before that helped us to create the interaction terms. Again, once you're coding, you have to be patient. So BMI and age, BMI and gender. Now I think the next will be age and gender. I'm just going to copy that, paste here, and then next is going to be the full interaction terms. Going to be here, BMI, age, and gender. Paste in there. So that's going to be our X variable. Let me see. Insulin is not here. That's cool. That is okay. That's good. And then we'll say X var. Again, I want you to notice that I'm using all upper cases here versus I'm going to scroll all the way up to show you the difference. Here I used lower cases, just only here was uppercase, but everything here was lower cases, just to separate that so that you will know what I'm doing if you want to rewatch this video, this recording. Add constant. Again, X var all uppercases. I will just say here is to, let me just go up here and copy what I did here earlier so that you know that I'm doing something similar. Add constant for intercept. If you want to see how I did the other one, just watch my previous video and you will understand. So I did that, and then I will say here that y var, that's y variable, is SQL data. I'm going to keep it the same thing as The reason why I'm going back and forth is to show you, is to try to demonstrate that I'm maintaining consistency. I will just copy the same thing here, actually, because it's going to be the same predictor, criterion variable. I'll just paste that here. Great. Next, I will just come over here and say print x var dot, let me just say lock for, and then I will say print y var lock for. Now this is the same thing as this. This is for columns, this is for rows. Like this is for rows, but I just did this just to show you that it's still gonna work. I'm just gonna come over here and then say print to separate them out. That I'm like aesthetics just to show you that. Okay, now these are our interaction terms that we have created, and we're just viewing them here. Next, we're going to execute the three-way interaction model. Oh, let me change this to Markdown. Let me just say moderated moderation. That is three-way regression or three-way regression. Interaction. You know what? I should not have done that. Let me change it back to actual code. That should work. Then I will say regression model underscore three-way model such model was y var x var output, but this time I'm going to name this one as three-way model. Just copy that. It's here. Now we'll feed that. Now print output summary. Oh, that output was going to be this. Okay, now let's run that and see. Great. Now, what we have here, let me just check the R square quickly. See, we have 36% here versus, let me see the first one that we have without using the interaction terms, versus 33.9, which is 34. So that is good. This is better. Okay, so next we're gonna split this. Let me just say here. I'll just say split data set train, set, and test, set. So I'm gonna stop here. We did a regression model here. So let me go over this thing really quick. I'm gonna start here. The Dublin Watson status is close to 2 again, which means that the residuals are are not autocorrelated, which is good. The residuals are okay. BMI here significantly predicts, again, it validates, it significantly predicts uh, 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 insulin. Uh, the interaction between BMI and age also predicts insulin. Zero. The interaction between BMI and gender also predicts insulin because this is lower than 0.05. Same thing with age and gender, but we are not going to use this. And then this full-term interaction model also does the same thing. That is really interesting. That is really interesting. Uh, we will go ahead and then in our next video we will compare these two models and see how which one that we will choose. Thank you. Let me see. So this the constants was that. That is good. The coefficients, the betters. That is good. Okay. So yes, in our next video, we're going to compare these models and see which one to select. Thank you very much, and have a nice day. Okay, bye.